Hello everyone, I am Parth Panchal and I'm honored to be here today as a Google Summer of Code contributor with OpenMRS and ICRC. Today, I'm excited to share my experience in developing an offline capable Android application specifically designed for low and middle income countries and integrated with the enhanced OpenMRS 3.0 platform. So, what was this project all about? We had several key objectives in mind. First, we aim to create a white label application. This means that the application is flexible and customizable, allowing future implementers to tailor it to their specific needs. Whether they are addressing unique healthcare challenges or catering to niche use cases, this application can be adapted to fit those requirements. Second, we focused on offline functionality. In many low and middle income countries, reliable internet access isn't always guaranteed. We wanted to make sure that healthcare providers could continue their vital work without interruption, even when there is a connectivity issue. That's why we enabled offline patient registration and editing capabilities, so no one is left behind regardless of where they are. Third, we needed to ensure that users could download patient data from the server, including details about their visits and encounters. This feature is crucial for providing healthcare providers with comprehensive patient records whether they are offline or online. Having this information at their fingertips means they can deliver better, more informed healthcare. Fourth, we placed a strong emphasis on user experience. We all know that technology can sometimes be overwhelming, especially in high pressure environments like healthcare. That's why we made sure the application is simple, intuitive, and easy to navigate. This way, users can focus on what really matters, caring for their patients. And lastly, we wanted to make onboarding as seamless as possible, so we provided clear and straightforward documentation. This makes it easy for future implementers to set up and start using the application quickly, reducing the learning curve and ensuring that they can get up and running in no time. Now let's dive into the project. First, let's take a look at the backend setup. Once the backend is fully Dockerized, this is how the container should be configured. Our application is designed to interact directly with Keycloak for authentication and the gateway for secure data transmission. This setup ensures a seamless and secure connection between the front-end and back-end services. Moving on to the design changes. Here's a screen you might recognize from our mid-evaluation demo, featuring the home, patient list, patient registration, and patient detail screens. We have made significant updates to these screens to create a cleaner and more intuitive interface. With the help of the structured data capture library, we have been able to refine the registration screen, making it more user-friendly and efficient. This allows healthcare providers to input patient information with greater ease, reducing the time spent on administrative tasks. Additionally, we have enhanced the patient detail screen. It now clearly indicates which patients are unsynced, providing immediate visual feedback. This feature is crucial in environments with intermittent connectivity, ensuring that healthcare workers are always aware of which data still needs to be synchronized with the server. Now let's dive into the application demo. We'll start by exploring the patient details screen. First, we'll look at a newly created patient who is still unsynced. Next, we'll take a closer look at a patient whose data has already been downloaded from the server. You'll see how the application seamlessly displays all the completed visits and encounters, giving healthcare provider immediate access to comprehensive patient stories, even when offline. We also added the ability to edit patient information directly within the app, and we'll be demonstrating it by adding contact information to the patient. Now, I would like to quickly touch on some key technical details that are crucial for future implementers. Firstly, the handling of patient identifiers is critical. OpenMRS allows for both required identifiers and auto-generated identifiers. It's essential that the application consistently selects these required identifiers and keeps user informed throughout the process. This ensures that the patient data remains compliant with the system standards and avoid any potential data integrity issues. Secondly, embedding identifiers directly into patient records is a must. For auto-generated identifiers, it's important that their values are fetched and accurately embedded into the patient's profile. This step is vital for maintaining the consistency and reliability of patient records across the application. Lastly, we have implemented the edit functionality using a pure FHIR approach. Instead of a conventional method of directly mapping the questionnaire response, we have opted the fetch local FHIR resources and populate them with the questionnaire. This ensures complete data accuracy, which is absolutely critical when dealing with healthcare data. Also, by adhering to FHIR standards, we are not only ensuring data integrity, but also making the application more robust and interoperable with other systems. So, what's next for this project? We are excited about the prospect of integrating dependency injection into the application. This will help make the codebase more modular and loosely coupled, significantly enhancing our ability to integrate tests and maintain the application over time. Additionally, we are looking forward to collaborating with future implementers to help them integrate with the OpenMRS ecosystem. In closing, I want to express my gratitude to the OpenMRS ICRC and Google Open Health Tech team for their valuable support throughout the Google Summer of Code journey. A special thanks goes to my mentors Jose Francisco and Frederick Deniger for their continuous guidance and invaluable feedback. Your support has been instrumental in bringing this project to life. Thank you all.